and a little audio. All right. On the air. I don't know if anyone's live out there in Twitch or YouTube land yet. It's hard to watch them all on one laptop here. Sorry to say, chat. Twitch wants to quit showing me. YouTube seems to be doing all right. Twitch says I'm live, but I don't see a picture of me and I can't see the chat. Keep telling it I want to watch myself, and then it keeps telling me it's offline. Go figure. So I don't know what's going on over there. But then things wouldn't be things if it wasn't for that, right? Mute my phone a little bit here so that it doesn't come up with something in the middle of it. Cheers. Well, if anybody's out there, say something. Theoretically, I should be able to see on both YouTube and Twitch and Beam all people who pop in, or especially if you chat something. Hopefully that'll work. I'm trying to monitor all three. I've never done this before. It is something new. Although I have streamed to all three platforms, I haven't ever really looked for the chat. I see Paul. Hi, Paul. And that's not coming through on the main chat for some reason. Send something else there. Let me see if I can get this synchronized, huh? Oh, hey, there's John from Fairbanks, huh? Guess what? We're going to be leaving for Alaska in about 2 weeks on July 5th. Take a little cruise tour. So we're going to be touring on land to McKinley and Denali. Not all the way up there to Fairbanks, though. And so we're getting all set for that. I got to go out and buy some cooler weather clothes, but how cold it'll be out there walking around the mountains. It looks like it's about 60 or 70, not too bad. So almost up in your neighborhood. Heck of a lot closer than Texas anyway. Let's see, I guess you can see me along with the Geocron. I just put that on there to hold it while I was trying to get the streams going here. Still not sure if Twitch is doing any good, but say about that. Well, we'll just see. All of the chat's supposed to come through to Beam also, and I'm not seeing it in there. So I'm gonna have to talk to him about that and see what's missing. Theoretically, it's supposed to funnel it all in. So, anyways, see the Geocron and me. Okay, that's cool. So my main PC blew. Actually, Sunday night, perfect timing, just after I had him put out the bulletin that I was going to do this. And I was rearranging the monitors on the desk here, and I turned the thing back on, and it said it was 109C on the CPU, and the water pump RPM was 0. And so I took that as a good cue to turn the dang thing off as quick as I could. So I ordered a water pump Sunday night, and I would have thought that it would have made it here by yesterday. For paying for priority mail from Florida. I mean, shoot, it should be 2 days from Florida, but in any case, I'm not even sure if it's arrived yet. So I've got my laptop, and that's it, although I've got it plugged into one of my monitors and then the laptop itself, so I've kind of got two screens going in that sense. But boy, it's just not what I'm used to at all for streaming and stuff. And as far as stacking things on top of each other to be able to see what's going on, try to keep it all working right. Well, I guess I'm going to have to watch the chat in each of the rooms. I was hoping it would all show up on this funneled thing. Beam is a new streaming service, and it's actually what's relaying it out to Twitch and YouTube. I guess part of the problem could be the horsepower of my laptop. Hello, Glenn. Not really made for doing this kind of stuff anyway. It's probably pushing it to a limit to be running both screens and have that going on out there. Anyways, I'm going to fiddle with it for a second, and I was going to have, oh, now I see, well, it took it a while, but all the chat just appeared over on the beam, the funnel, if you will. So 2:05, so yeah, it's apparently a couple minutes behind as far as, I don't see a timestamp on it over in YouTube there, but we done discussed everything about it before it showed up. Showed up in the beam, so there we go. That might be more live. Hi, Glenn. Presentation working fine in Austin, Texas. All right. So we got 3 Texans here already. That's kind of I don't know. I wonder if that's legal. And we got some other people joining in. But on and off real quick. I think the beam picked it up finally where I'm seeing all the chat. That'll be good. Because that's what I planned on, to be able to do that. Now, I was going to also show a bunch of pictures, but guess what? Without my big PC there, Diana, I don't have anything but access to my Office shared files, which are pretty much just my presentations from past years, which you may or may not have already seen. But actually, the one from Symposium last year had a lot of good slides that might be useful in answering any questions about what we're doing, or might be worth going over a couple things. Let's see how this works if I try to stream it. Gee, I hope everybody's still there. It says I just quit watching. How did I work this out here? I'll put the display here. There we go. Kind of covering up part of it. So if I do a slideshow and have it do it on the current screen, that'll let me make it big enough for see. This is something I think is really cool, and it just occurred to me when I was asking for something unrelated. I was asking everybody how long they've been, working in engineering, and you can see that there's a few old heads like Bill Reed and NX5R and N5BRG, who's like, I'm so good at names, I may forget them here probably. But, been around since the 80s working with AMSAT Engineering and W8ARU. And then you get pretty much the bulk of the people that are currently there started around 2013. So it's back in when we started the Fox 1. The ones that stayed, they're not by far not the only ones that were there. I started in 2011, for example, and I'm not on the list here, I don't think. So, I started 2011 as systems engineer, and we're still around. Nothing like some good old relics, huh? Let me see. This is kind of covering the chat. See if I can there we go. Sorry about that. I'm so adept at this. I stream all the time. And then it keeps wanting me to make money. Do you want sponsorship or do you want to monetize? And it's like, no, I just do it for fun. So there you go. 2013, we got a bunch of people that joined in for Fox. So 2013 up till about 2020, 2018 anyway. And then that's when we get into the golf program beginning. So you can see that we got a lot of new engineers. Since about we're running in there, it's a little over 2020. So in the last 4 years, quite a few people have joined in, and that is really great because we have a lot of new people with different skills. We also have some younger people. What was that? And so it's a really good combination. Get that back here. There it is. So I mean, that's pretty good stuff. And then that was just a breakdown of it. But always human resources has been kind of our tricky part, because everybody's doing it for a hobby, right? We all do it to fill in for some time, for some fun, and like sitting here right now, it's all just because you like to share what you're working on. So since I kind of work on overseeing the whole thing, there's a lot more to share in particular, but the everybody who's doing their part for it, what makes it fly. They're complicated. There's a lot of stuff in it. The reason that they're complicated, why can't you just put some little parts in it and fly it, is because we want it to last for a long time. People spend years making it work. You could spend less time making it work, but it's not going to be the robust ham radio that hams want, right? Nobody wants to spend some time building something for it to work for like a week and then, okay, that was fun, and walk away from it or so. Cheers to Virgin Orbit, who fortunately was around long enough to launch Fox 1E. So I don't know if you got anything else you want to ask about. I'm trying to glance through the slides here, see if it's worthwhile to talk about. A look at golf. I think keep track of my golf here. Okay, I'm still in the picture, so let me remove that just real quick. Yeah, right, real quick, he said. There. So now you can see the whole of the golf tee. Next slide, I think, blows it up a bit. This is slightly changed because this was, from Symposium last year, and that's how fast things change, right? Let's see. There we go. Oh, look at that fancy stuff. So we pack a lot of stuff in these satellites. There is just a ton of insides. Now, this down here, this stack on the bottom, which isn't really the bottom of the whole stack, but it kind of represents the size of the Fox 1. They had, I believe, 8 PCBs in them, and that just filled that thing from bottom to top. And here it's tilted on its side because we had to accommodate for ADCS and some other things that primarily the EDIS 310 that drove it is the SDR for golf. And so that board could not be modified, and it was a certain size, so we had to tilt everything else to cram it in there. This is a bit older drawing, actually. We don't have a new complete one, but you can see that, it's just full of all sorts of stuff, because especially radios. You look at a 3U that they fly these days, the universities or who, 30-minute launch window. Let's see. I'm reading what Paul's text said here. The 30-minute launch window will open at 9 p.m. 9 p.m. Wednesday, June 26th. What 30-minute launch window, though? Article is just posted, so you're not sure if I'm aware. I hope we're not launching golf. That would be a bit too much of a surprise for me to stand, I think. Is that a AMSAT? Oh, okay, cool. I guess if somebody mentioned that in the chat, I didn't see that part. So AMSAT, that's excellent. Well, AMSAT is flying the what we call the LTM linear transponder module, and that's an offspring of the linear transponder and IHU that flew on AO 109, Fox 1E. The original design was Fox 1E. Then we took it and made it into the module, which we just put an IHU on top of the transponder effectively in order for it to be able to mate with the bus, which is typically PC104 type of connector, of other satellites so that we could have partners such as University of Washington flew the first one that basically we kind of got a ham radio satellite without having to build the whole satellite was the idea. And so Maine, which is up there in the same neck of the woods as Burns and Eric Skoog, they worked really closely with them too. Burns and Eric both worked with University of Washington to help get it integrated, being the first time. And they did the same thing with with Maine. And we've been waiting a long time for that launch. And as we all know, it takes a long time for launches. Whenever the satellite's ready, or even when it goes on the rocket, isn't necessarily when it's going to fly, and especially with some of the newer launch vehicles that NASA's sponsoring. So MESAT, or MaineSat 1, launching Wednesday. So about 3 or 4, well, let's see, Friday, right? 5 days from now. That's cool. We should tune into that. Are you going to do a stream, Paul? Or how did you do it before? Did you do a live stream on that? I forget, when we launched 109, for example. So this will be a good test of MESAT. We had a little trouble with LTM on the UW HuskySat because of reasons unknown. Originally, they were going to license it, but they did not get their paperwork taken care of in time for that. So what we wound up doing is they flew their mission, then they gave us the satellite, if you will, gave it over to AMSAT, and we became the control op owner. And so we don't know what might have gone on. They were testing a propulsion system, electric propulsion, and so one possibility is that all of that EMI just kind of cooked the LTM a bit, and we knew that the finals, that the PA on the LTM was sensitive. In that design, we found that out with Fox 1E, and actually Fox 1E turned out to be very low power because of that, probably. I blew it up in Fox Labs here, testing it twice. Once when I touched the antenna, which messed with the SWR, and then the second time I was testing with Clayton Coleman, ex-president, and he lived about 1,000 feet away. So, around here, there's no blocks to speak of, but it's a few houses down. And I told him, turn your antennas away from it 90 degrees and use low power while we're testing, or this thing will blow up. And he had to find out for himself, I guess. And we blew the final just on his strong signal. So we don't know what happened to HuskySat. It's a short story. So we had reworked it between Fox 1E and HuskySat. Then we reworked it some more between HuskySat and MESAT, although MESAT is actually flying the flight spare for HuskySat. So it's not the latest generation, which is actually still being cobbled together, if you will, for both Golf T and to be used on Fox Plus A. So that's where we stand with that. It will be very fun to see the LTM working on MESAT. I'm not sure what their orbit's going to be. I think they're flying on a Firefly launch out of Vandenberg, so it's obviously going to be polar, but altitude unknown. I guess the way that I learned from CubeSat Developers Workshop was that, talking to NASA, essentially the type of launches that you can get, that would be in the class that goes up maybe 400 kilometers or so. So I don't think they're going to be as high as 500, 550, which is where we want to press Golf 1 to. Because we like that lifetime. Not only that, but the footprint. Greater orbit, larger footprint. So there you go. There's some background on that. And Paul says we have and I'm repeating this because of other platforms. They may not see the chat between like Twitch and YouTube, if Twitch is even working. But so you said you had a live chat in the past. Are you going to do anything for MESAT? How's my audio, by the way? And if you don't answer, I will take that to be it's fine, because the alternative's no fun. Let's see if I can get out of this here. There we go. Golf T, blah, blah, blah. We got a IHU. Paul says audio is good, and are you going to have an event for MESAT? How come it says I'm live over here on Twitch, but I can't see myself? Maybe I'm not supposed to be able to see myself, which makes perfectly no sense. I'm about ready to give up on that. Here's a chat room. Whatever. Yeah, checking the old Beam profile. It says YouTube just live. Twitch is live. Okay, cool. So, yeah, I don't like having the camera up so high either. I like to look at it while I'm talking. But I got to stack these screens up here basically with my laptop on the desk and the big 4K monitor on top of it. I was going to play a game in the background too, just for dinking around. So between people showing up and chatting or whatever, I'm glad there's a bunch of people here. It says, Glenn, audio's fine. Thank you. And NASA just released, just released the notification of MESAT launch. So I guess you're all on YouTube, actually. I don't see anything going on Twitch. Cool. Did you put anything out on it? I'm sure Burns will be excited about it. He's been waiting and waited. He might have emailed something, but I have email going right now because it just doesn't fit with it. Here's a picture. Come on. This has the 3D printed. Anybody? No audio, video on Twitch. Okay, thanks. K7TA Bravo. So what the heck? You know what I'm going to do? I'm going to stop and restart that real quick and see if that makes it happier. I might have done something. Like I said, I'm kind of new at it. So if I kill that, hopefully I'm still going on YouTube, huh? And did I just die on YouTube? Nope. Okay. How come I waved my hand and I never saw it? Maybe I'm, wow, maybe that's a big delay going on there. That's what it is. There I am wiggling around. Gee whiz. Like I said, I mean, I don't stream stuff. If I do stream stuff, I'm just streaming it. And I'm not looking at what it's doing or what it looks like. So I turned the Twitch off and on again. K7TA Bravo. I should know your name, but if you can check that out again in I don't know, maybe 30 seconds. It seems to be that much delay, at least to YouTube. If you can check that out, I'd appreciate it. Let me know if it's working over there, and copy you, Paul, on working on the ANS. That's why, yeah, let me know, honest, everybody be honest, right? If this stream is worth it, because since I blew the water pump, like the day after I begged everybody to put the thing in ANS, I figured if I'm not going to get the water pump in time, I'd better try to figure out a way to make this work. Hopefully this makes it work. Then I'll do it again at 7 o'clock tonight, and I can make some improvements perhaps. I didn't even think about the fact that tomorrow's field day until I got a call yesterday from one of the club buddies that said, hey, don't forget field day. And I was like, well, I'll bet you that one's going to be a live stream here tomorrow, unless there's a bunch of people like me who probably wouldn't be at field day anyway. It seems like the older you get, the less you go, because you've done that a few times maybe in the past. And besides, it's July in Texas, or not July, but June in Texas. It may as well be July. So if you want to look at the forecast, 99 on Saturday or something. I mean, it's just supposed to, it doesn't matter when field day is, it's going to be 100 degrees. there you go. What else can I talk about? I don't know if this blows up here, this particular slide. Let me just hit the slideshow and see what happens. There it is. Well, you see down here in this lower right image, that's from last October, the 3D print that Tom Karnauskas had done on the work he was doing to try to figure out how we're going to stack all this stuff inside the space frame. And on the left, the representation, the current one at that time. And I think that pretty much still holds. I think we got one less set of batteries. Forget. Tell you the truth. Yeah, I think we're just carrying 3. In any case, that gives you an idea of the work. And you see then that stack on the left, that vertical stack, the one where the letters are all in the right order. So you've got the experiment, which is the Vanderbilt University, and that takes up 2 slots because they have their VU controller, and then they have the LEPF, which is the low energy proton experiment. Then the RTIHU, that's new, of course. A ICR, the ICR is the command receiver for the, sorry, I got distracted again. It's the command receiver for the LTM. And then right below that, the RXTX, that's the linear transponder. LIHU's the old legacy IHU that flew on all the Foxes, and well, tweaked a little bit to work with the new LTM. And spare is a spare. That might possibly then be the place that would house the experiment for San Diego. There's a high school that was interested in San Diego that was interested in doing a camera experiment. I don't know how interested they've been in how long it takes to get something to put together and launched. So, but they're, as far as I know, last time I talked to them, still holding on to go fly out on Golf 1, and so take some pictures. So they could put their computing hardware there, if you will, and then we'll stick the camera out, probably the -Z end where the antenna is for 10 gigahertz. And the EDIS 310 that I mentioned before, that's it right on the bottom there under the Fox type stack, if you will. And that's why we had to make this goofy stack up, because it wouldn't go in either of the stacks there as far as fit. So we had to put it on its side, turn some of the old Fox stack there on its side too, in order to accommodate it all within the 3U space frame. Now there's work that they're doing, Ray and Rich in ASCENT. ASCENT is the skunk works with typically everything going to open source on there, or open access. I'm not sure which they call it. The idea is to develop things for future use that are, well, advanced satellite communications and exploration of new technology. So they're working on what they're calling SDRB. SDRB is actually taking basically the EDIS setup and creating it on a 4x4, which is a rough approximation of the size of PCB that fits in a typical stack. So that will help a lot if that's completed in time for Golf 1 especially. It should, give us a lot more space within the space frame for PCBs and our flight experiments and such like that for the future flights. So, God, I tell you what, I'm so used to having 3 monitors. It's like crazy trying to go back and forth to all this stuff. There, wrong one. There, put that back up there. I was watching, speaking of Fairbanks, and I was watching Alaska on this. I got up yesterday morning, and I came in here about 7:15, I think, and I looked at I had left it on overnight, just coincidentally, but I went and looked at it, and I noticed, John, that the sun rose up there while I was looking at basically Denali, which is the farthest north we're going to go. The sun rose up there about the same time it did here, except that we were, at 6 a.m. and it was like 3 a.m. or something out there. 4 a.m. probably more likely because the time zones don't exactly line up, I guess, So yeah, I think you're 3 hours different if I recall correctly. So, but that's going to be weird. I mean, shoot, I stay up all night as it is, but usually, even on my worst nights, I'm going to go to bed before the sun comes up because if the sun comes up, it really wrecks your sleep, right? So it's going to be really interesting there while we're hanging around up there. Better than being dark all the time, I guess. I know that that's not far enough north to be dark all the time. It's pretty interesting watching that roll through. You see, the geochron puts a way different look on stuff, and for what it's worth, I picked that up at not actually at, but right after looking at it at Hamvention last year. So I went, hey, you know what? I can get that because I always wanted one for the wall. They're right expensive, but you got to have a lot of wall too, and I don't have a lot of wall. So you can see probably in the camera there's a whole bunch of windows behind me. So I thought, oh, you know what? You can get a TV for like $300, and I got enough wall to put a mount on it. So there you go. Go to town, huh? And it is very cool. I just centered it. It's got an option to center the display with the ham radio part. So it's just going to stay centered on me instead of scrolling the globe underneath the sun, if you will. It's going to scroll the sun across, and then that way I'll be able to see the effect up there in Alaska a little bit better because it would get hidden behind those aurora zones that are in the upper right of the display as it scrolls along. Well, let's see if Twitch went anywhere. Well, I see A7TA Bravo, your no audio video on Twitch chat is showing up on the Twitch chat. So I don't know if the damn thing's working or not. All it's got is a still picture of me, but it says live. So I don't know where the heck the stream's going. I've streamed games to it. I did it the other day. I streamed to it. So I don't know what's different about live streaming, me, or maybe I just don't know how to look at it because every time I ever looked at the game, it was after the fact. And I go back and say, hey, check out this stream from N0JY yesterday or whatever. What the heck? What else should I talk about here? It's only been 30 minutes. It feels like 2 hours. I gave up on Twitch. Are you talking about watching it here, you mean? Chris, it says it's live, and after you bounced it, it saved the video. Oh. Well, you didn't miss anything then. That's not good, because like I said, it would play the games. So I don't know what's going on with that over there. Thanks for the report. I did a test there the other day. Well, you know what? It could have to do with my laptop. It may not just have enough horsepower to be able to accommodate what Twitch is expecting as far as the video reliability or something. And YouTube's a little more forgiving perhaps as far, because when I looked at it, I think YouTube said, hey, yeah, wow, you got a excellent connection. And I don't know where Twitch says that on there if it does, so live and learn. If I got the water pump's supposed to be here today. Would I be able to install it tonight for tomorrow's stream? I probably could, but I'm not sure that's one of those things I want to do because I don't like to rush stuff like that. And besides, it's working tough in there. Jerry, can you talk about the radios on Golf T, uplink and downlink bands and formats? Sure. Let me get a quick refresher here. Best water around. So, you know what? I'll go back to that image too. Maybe that'll give a little something to back it up with, because you can see exactly what's on there in this particular one. I'm not going to make it, I'm not going to blow it up this time, though. So let's see, where am I? I got to pull out OBS and all these different things from different holes, so it takes a second to figure out what the hell I'm doing, basically. Okay, so yeah, the radios. Well, you can, let's see. I'm going to scroll back real quick and start on the outside here. This here slide. So over on the right side of the slide, you see sticking out of the back of the Golf T, basically, a little PCB, and I think that might be the best view that there is. That is what we call the wideband or multiband antenna that Kent Britton designed initially. It was there for 5 gigahertz uplink, and we added the ability to do the L1, L2 GPS. We added the ability to do 70 centimeter receive, and that's just to pick off the signal from the 70 centimeter transponder downlink, so it's nothing for an uplink. And we've got 1.2, 2.4 capability with it simply because it's wideband. So it's not tested or designed specifically for those, but those little patch antennas, you can see one of 2 brown circles there. That dual band patch array is wideband enough to be able to receive 1.2, 2.4, 5, and probably maybe 10, but it is set up for that. So what we have then with the radios is, there's some stuff in here. ADCS, here we go. SDR. So the SDR, 10 gig for the 10 gigahertz downlink primarily, is the EDIS E310, and you can see a picture of that there in the lower right. And that was chosen a long time ago. It goes back to the Phase 4B. And when that was being worked at the time, it was hoped that EDIS would be able to let us take it apart essentially and reformat it so that it would fit on that 4 centimeter board, basically, or 4-inch board. And that did not come to fruition, I think, largely because they had a change of leadership. And so we lost the connection there or something to that effect. And so we had to fly it as the PCB that it is in Golf T. So that's why it's basically, you see the picture of it there on the stack. It's the EDIS E310 without the case. And that's going to provide then primarily the 10 gigahertz downlink. That's what's on the CSLI, the CubeSat Launch Initiative proposal that I wrote back in 2017. Was one thing we wanted to prove was a high speed data downlink capability on 10 gigahertz. That's something that came from another CubeSat developers workshop where universities and well, primarily that's the partners we have, universities were interested in being able to get more data faster. See, Vanderbilt was very happy with even the data under voice, 300 bits per second or so, that we could do with the Foxes because their low energy proton experiment, they're just looking for an upset in one of the memory chips, basically. And so there's not a lot to report all the time. And they're looking at, you know, so the amount of data flowing was not that big. And then they just looking through what they captured and to see if there was a change. So the 9600 bits did okay for the Virginia Tech camera experiment. They had to stitch the picture together, which is why a lot of them have that separation line in the middle. It knocks the top half and the bottom half are not, matched up because that was because of the buffer on the camera, though. So they can only send half a picture to the IHU at a time, and then they take another picture and send the other half, and that's why the satellite moved, of course. Yeah. You got a little bit difference, that tear line there. So that would have been able to handle that fine. It took about a minute to get a full image, 50 seconds if I recall, and the ability for a lot of stations to receive it. And Chris Thompson did a great job of stitching it back together at the server with what came in from the Fox2LM software. That's 9600 bits per second. It's practical for certain things. Not, hang on, I just got a pop up here. Yeah, right. It wants to update my Thunderbolt firmware, and I'm not even using Thunderbolt. Why do these things happen when, when you're in the middle of a discussion? I'm getting so old, now I got to go, what was I talking about? So, yeah, high-speed downlink capability. Now, at Leo, that's going to be a trick. You know, we're going for one megabit, which is not really that much high speed, but this is an experiment. And I think that we'll be able to demonstrate it. I don't know if it's going to be real practical as far as receiving that data downlink for users, although everybody that can help, you know, obviously that's a help. The thing that came along, and this was a while back, so maybe 2019, not too far into the program, which started 2017, Golf did, was the idea of putting that 70 centimeter pickoff on that wideband antenna. So what that does is a little squiggly line on there that's going to pick up the downlink of the VU linear transponder LTM, so that the SDR then is going to pluck that off and repeat it on 10 gigahertz. So we have that 10 gigahertz 4-patch array on the -Z, the bottom end, if you will, the earth pointing, nadir pointing end of the satellite. And that too is very wideband design, so it covers about the whole earth plus. And Kent says the signal off the sides is actually better than the signal straight down. So it's made to, you know, be able to help aid the fact that Leo goes by real fast. So the Doppler is another trick, but Ray had some ideas that he's been worked on and using a pilot frequency, so that would help keep you locked into the Doppler. I'll let him describe that. I'm sure he has, but you know, more detail on that as we get closer to actually using it. And so that would be able to allow you to work the VX, or VHF uplink, X-band downlink linear transponder, and open up some new opportunities for people. The idea behind that being we want to move to the microwaves because, well, you know, obviously if you do any of the satellite work, and I don't even do it, but I know it, the VHF and UHF bands are so crowded, there's satellites stepping on each other, basically. And so there's a lot of bandwidth up at microwave, and then microwave also gives us that benefit of the smaller antennas. You go back to the idea of the wideband antenna sticking out the end there. And where'd that slide go? In any case, you know, that gives you the picture of the fact that all those microwave frequencies are on that antenna, and it's, you know, about 1/3 the length of the satellite, so it's about 4 inches, more or less. It folds up against the side, gets deployed, pointing down again, and so the microwaves, the farther away we get as we go to HEO and beyond, it makes it a lot easier to make up for that path loss with the gain of the antenna, because you can put a lot more gain into a lot littler space. VHF and UHF with just your whips, or figure out how to put a gain antenna on a 3U satellite for those bands, you know, it's going to get pretty tough. Yeah, you could work FT8 or FT4 or something like that. You know, you could make contacts, but it seems to me that that would be kind of limited in what you can do, especially like when you're kind of working the same people, although we hope to attract more always, but you know, you're working the same people. If it's doing it with FT8 or FT4, it's not even a conversation. It's a lot funner to get on there and try to work together and like, how's my signal? How's my audio, right? So that's the microwave part, and it's really exciting. Then with Golf 1, unfortunately, Golf 1 is still going to be stuck in Leo, so to speak. We'll just make some advancements with that, not probably, but intentions are to open up 5 gigahertz uplink, so we have the 5 and dime, 5 up, 10 down, and also 2.5 on the uplink, 2.4, because of what work they've done over there on the European side, if you will, with QO100. So they've developed a lot of 2.4 gigahertz uplink, 10 gigahertz downlink systems. And so We have crossbreeding, if you will, between sharing the 5 and dime and then the 2.4 and 10 capability with the one satellite. And the idea of using that on Golf T has been discussed, and I think perhaps a little bit too enthusiastically in a sense. The possibility is going to be there, and here's the way I've approached the program. Golf T has to meet certain objectives for NASA to even fly it. Okay, so the RTIHU, the deployable solar panels, the ADCS, and the SDR, 10 gigahertz, are all requirements of the mission. Actually, the ADCS kind of got de-scoped. We're flying a commercial one because the partner that we were working with, which would have allowed us to be in on the development of the ADCS and be able to learn it and possibly even adapt it in future missions, well, that went away with the company. So we're working with a commercial ADCS, but the rest of it is all still a requirement to fly. You can't take that away from what they wrote. You know, I wrote the grant proposal and they said, we'll pay for the launch for this. So you got to launch what you said you wanted to launch, basically. Therefore, we need to know that the deployable solar panels work so that we can fly Golf 1, or whether we have to improve it, change it. Anything that we can learn to improve it, of course, is always good. But will it work is the question. So proving the ADCS to be able to stop the tumble, point the satellite, deploy the solar panels so that they can point at the sun primarily to get the extra power that you need to go with all these fancier new radio systems, STR's gulp power. And that's not the only thing, of course, the ADCS. But so got to be able to point those solar panels, got to be able to deploy them, got to be able to point them, got to be able to get the 10 gigahertz downlink pointed good enough to be able to do the demonstration of that. And we need to run the RTIHU through its paces with the LIHU, the legacy IHU on board. The LIHU, the LTM module, IHU, improved command receiver and transponder are all part of a big backup plan, okay? So if all the new stuff fails, we should at least have a VU transponder satellite working to the extent that we have power. But beyond that, the RTIHU then is supposed to mitigate a lot of the resets that we saw with the Fox satellites, especially going through South Atlantic anomaly. And as we go higher into more radiation, harsher radiation environments, the RTIHU is hopefully a device or a step forward to being able to deal with radiation mitigation with COTS parts, with off-the-shelf stuff, without having to get the more expensive hardened or what have you. So we have, as everybody developed it, and because this took time and we had the setbacks with the loss of the ADCS, we had a big setback with the loss of Bob Davis. So with the extra time that we have had as systems were developed, primarily the radios, then there, it's like, hey, we could add, for example, the 70 centimeter pickoff and downlink. Yeah, that's a good one. That's fairly easy, and it's great to take us to the microwave stuff. So we're going ahead with that. 5 gigahertz, 2.5, 2.4, and 1.2 gigahertz uplink. We'll probably test that, and because we want to know basically if it'll work for Golf 1, but I don't know, and I don't expect. I don't plan to have it open for everybody to use. Now, it's possible it works great and we could do that, but I don't want anybody counting on it. I don't want, the idea. So what it's done is it gives the engineers, the guys that develop, the opportunity to develop what is going to fly on Golf 1 and put it into Golf T, that we can test it to an extent. And that just gets a leg up, if you will, on putting Golf 1 together and having that in it as a working planned system. So that's how that works. Golf T's got it on it, may not use it. Golf 1 will definitely use it. 5 and dime is in the future. No, 5 and dime's here now. Anyway, so that's the plan with those radios. The LIHU, the 70 centimeter, VHF UHF, so 2 meter 70 centimeter transponder, is there for a backup. And if RTIHU performs well, I do not expect to fly LIHU nor the linear transponder package, LTM, on Golf 1. The SDR would do that work. If SDR and RTIHU work together. And that's a possibility. I will always keep it there, ready to throw in Golf 1 if it doesn't, if things don't work out with Golf T. But if things work out with Golf T, then we would want to go with the new systems on Golf 1. So but keep your CYA, right, with a backup, so that, like I said, if everything else were to die on all the new stuff didn't work on Golf T, well, you know what? If we have a VU transponder radio up there, then that's a win in that sense, the amateur radio part. So how's that? That was a long answer. Thanks. Burns up a lot of time. But it's fun to talk about. There's a lot of stuff that I never get to talk about. 20 minutes, 30 minutes, 40 minutes, even 45 or something, at symposium or forget about, Hamvention or even Hamcom at the time. You can't talk. You don't have enough time to talk about all this stuff in any kind of detail. So that's what I like about this, is that we can just go into the detail about that, and we can go into why is this like that, and the what ifs or wherefores, and if you raise questions about that especially, that's very cool. One thing I like about having the team of people that we have, and by far, and I've said this and you probably all know it, I don't really, other than like what I've just described, I don't tell them that, the team what to do. They all have their ideas and they know what to do about that. And so the guidance is simply in, this is what we can fly, what we will fly, or what we're capable of flying, what we can get a launch for. And so that means that, hang on, I'm sorry, I just got another pop-up here. Yeah, right. This is ridiculous. I'm looking at the chat and then I get these little pop-up messages about updating firmware and junk that I care about. So where was I? Yeah, I mean, as far as what goes on, everybody's doing their work, and I just keep a guide on it. So all of these ideas come from all the engineers, and everything that goes into it is very good stuff. And that falls back onto the whole thing about how do they work on this? Why do we work on it this way? Why are we flying what we're flying? But it did, the overall idea that I had put forth back when we had CQC. CQC was the partnership with Ragnarok and others back in 2015. We started that, ASCENT started working on that for the communications package. And that was where 5 and 10 gigahertz was chosen by a lot of people, Tom Clark included, to be the best cost-effective way of having a radio system, a transponder at the moon, or far away, if you will. Higher gain antennas, higher power SSPAs, of course, and like that. So the 5 and 10 is something that I put forth that, okay, if we're going to do that with this, we should do it with our satellites that we're going to go to microwave with. And I also persuaded, why can't I even think of his name here? That guy from Virginia Tech, right? Anyway, I'll think of it. But I persuaded him that phase 4B should not be 3 gigahertz, should be 5 and dime. So then we have all this commonality, and all the users, you got to get some new stuff, but it's usable on all the satellites. So the new satellites, Golf, Hotel, whatever, they can have 24 gigahertz, they can have 70, whatever we want to do. But the 5 and dime becomes the baseline there, like the linear transponder VU is the baseline now. And then that way you can work that new satellite far away, wherever it is, whatever it's doing, and at the minimum. So you get on your 5 and dime station, you can work the satellite and you can experiment with the new stuff, kind of like the way we're doing it right now with Golf T, VHF, UHF guys. Hey, guess what? You can get a hold of a 10 gigahertz downlink stuff pretty cheap, and give it a try. So I have a suggestion from Paul, 2 more ideas: attitude control and an update on the progress of Fox Plus. That there's your attitude control coffee. I'll say one thing for Virgin Orbit. You know, it was a really interesting mission with them. Virgin Orbit, they launched Fox 1E. They were a new company that NASA was working with to develop their airdropped rocket, for lack of a better term, and as part of their venture class. That's how NASA spreads stuff around. People say, you know, oh, they just waste all this money going to the moon or whatever, and there's no benefit. But all of the commercial ventures for space were somehow seeded by NASA. NASA does that stuff. And so the venture class that was more than just Virgin Orbit, but Virgin Orbit, was one of the things they pushed for. There's a fun fact to it. Maybe you know it, maybe you don't, but I've got another hour. So that the contract that NASA had with Virgin Orbit was that we would fly these CubeSats on their second launch. Okay? So not the second successful or whatever you want to put it. So that first launch where they dropped it and it just, you know, fired for some seconds and then kept dropping, that was the first launch. And we were going to fly on the next one regardless. There was no way out of that contract, and believe me, they asked them. But there was a sort of a light at the end of the tunnel because Virgin Orbit had a lot of money, obviously, riding on this. They had a lot of customers that were already lined up to fly, paying people besides NASA just giving them, you know, the $100K or whatever to launch the CubeSats. So they had called in a lot of experts. They were doing a lot of proper examination and rework of what the problem was, because if they didn't work on the next one, you know, they're looking really bad, and we were the next one. So there's a possibility that helped us to do have a better opportunity for launch, or a successful launch, and it did. I mean, you know, we got the launch that we were looking for. That's all very good. Excuse me a sec. Yeah, there we go. And fortunately, we got a good mission out of it. So where do I get this? That's where it all goes to. So the integration we did, and I've shown some pictures of it. I don't know if I have any handy here, but they had a great integration facility. They were very friendly. It was very cordial. It was well structured, although they were learning as we went along. And so we were actually participating a bit in some of the particulars about integrating particular spacecraft and such like that. So it was a fun deal with that. And I got a coffee cup, right? So the coffee cup is a darn good coffee cup. So they may not be able to build rockets, or they may not be able to run a company anyway, but they had a good coffee cup. It keeps it warm for a while. End of that. Okay. So hi, Angel. We're talking about AMSAT satellite program here. So Paul Stetzer had asked to thrown out 2 ideas for discussion: attitude control and an update on the progress of Fox Plus. So back to the attitude control. Let me see what is a good slide I have for that, if any. Yeah, well, the story with the attitude control is that we started with Ragnarok. Ragnarok was the one that I mentioned that was one of the instigators for that CubeSat Quest, which was a NASA-sponsored program for lunar CubeSats. So they were working on the attitude control system. What happened was, in that selection for who was going to get a free ride to the moon, which is it was like $1 million deal, right? Ragnarok or the satellite, Heimdallr, did not qualify, not in the top 3 or whatever it was. And so Luigi, president of Ragnarok, who we were working with, had talked to NASA about what can I do to fly my, attitude control system we're developing. And they said, do a CSLI, CubeSat Launch Initiative. So he, because we had, been working together, came to me and said, hey, can we do a CSLI together on this? And I said, hey, timing's perfect. We'll put it in golf, because that was right 2017, early 2017, March maybe, or somewhere in there. And so that's what pushed golf, really kicked it off a little bit sooner and a little bit farther ahead than what we had planned. We did not initially plan specifically ADCS. The plan for golf following Fox was to build a 3U and to learn by flying these various systems, ADCS, IHU, deployable solar panels, it combo as it works that way, or separate missions, so that we would learn all of this, including propulsion and such, to be able to get us to higher orbits, because we have to know how to work all that stuff. So the ADCS deal that we had with Ragnarok was a very good one, because they were developing it, we were working with them, and that gave us the opportunity almost. We never did get to the idea of a licensing agreement, but we understood what it was, that we were working with. It wasn't so much of a black box, and it was also a very lucrative price to be able to access it, to fly on. Actually, we had made the deal that we would get the good, not the same price necessarily year over year, but that good price for all of the Gulf satellites that we wanted. And turns out in literally the end, in 2021, that's a long time ago, it seems like. But I guess that's right. Golf T was on a launch. And ironically, it was a Virgin Orbit launch. But Ragnarok was unable to deliver their ADCS. So I went to NASA, said, look, we're going to have to find a commercial something. Can we de-scope the ADCS? We got to do that and start looking for a commercial unit. We started looking for commercial units. And but in the meantime, I also pulled us off of that launch opportunity. So we were able to get out of that without paying any damages or money owned back. And sorry, Angel, I was just reading your text there. The destruction you're talking about tomorrow on the streaming. I'll be on again tomorrow doing this. And by the way, I was having trouble hitting Twitch, but I'm not sure if that's my end of the laptop and stuff. I can talk about that later. So the ADCS, we had to de-scope that. We're off the launch. We didn't have to pay any penalty, because nominally, if you don't make a launch that you're booked with, contracted with NASA, you are liable to pay NASA back for the time, any time, time and money that they spent trying to get you to that launch. So fortunately, the Ragnarok deal got us out of that, as it was hanging on them to be, the responsible party for not making it. Yes, tomorrow. Thank you. And that was followed immediately, literally a day later, after I pulled that launch, we got an offer for Golf 1 with an Air Force launch, DOD. And yeah, we accepted it. And this is where it gets really crazy. Bob Davis, I am multi-streaming to Twitch. Okay, cool. Bob Davis, our engineer. I keep wanting to say chief engineer like Scotty or something, but anyway. We worked together on some documents to the Air Force that were more or less a bid. What is your current status? What is your likelihood, your reliability, risk? What is your risk of making the mission? Because that's very important to them. They don't want to be trying to take along CubeSats that might get, that might not make it or whatever, and that affects their, I'll say, weight and balance, just to keep it simple. But their whole mission timeline as well. And so we came in with good numbers because we've been working hard on it. All we needed to do was get an ADCS, and we could go with Golf 1. But I questioned NASA, do we really want to do Golf 1 ahead of Golf T now? And that was, well, it didn't have time to find out, because the very next day that I had submitted that stuff, that's when Bob Davis died overnight. And so I got the news of that 15 minutes later. I'm back at work getting a hold of Air Force to tell them, hey, I'm going to have to lower that likelihood of making the launch way down, because we just lost a big chunk of our workforce. And it's always been something on the CSLI is the highest risk to the mission is us, the people working on it, because we're all practically all single point of failure simply because it's hard to get people that are willing to spend this much time doing this stuff. Anyway, so we backed off of that one. So we're actually 2 launches behind. In the meantime, now we had a member join, Hilly Page. He had been out at University of Arizona, and I think he worked on CATSAT or worked with the guys on CATSAT. Did a lot of work on ADCS. So for us, he did a survey of what ADCS are available for our 3U CubeSat, what are the best options, choices, and it was a really great breakdown that led to the CubeSpace, which is a company out of South Africa. CubeSpace, it's ADCS that's available. You see it in the center of the picture on this slide. And hang on, I need another hit. Crazy water, I'm telling you. You get this over there, Glenn. HEB, anyway. So, the CubeSpace ADCS is what we're going to fly, and that's what we've been working on. The ADCS, then, this thing can be tailored for whatever your specific needs are. In one of the images, early images I showed of the Golf Tee structure, up at the top here, you might notice it mentions star trackers, because that was back with the Ragnarok ADCS. We were going to fly star trackers as part of what they needed. We don't need, after talking with CubeSpace, we don't really have the need to fly star trackers. We don't need that pointing accuracy for what we're doing, and that's fine, because less complications in something new like this, especially, but in anything satellite, the less complicated it is, or the KISS principle, the lower the risk, better chance it's going to work. So we only need a couple degree pointing accuracy. We need to be able to point the solar panels toward the sun for maximum amount of power, give or take a couple degrees, right? And we need to point the 10 gigahertz antenna toward the Earth, give or take a lot of degrees on that, really, but we need to be able to do that control, and that's part of what we need to be able to learn in order to maneuver in the future. You got to be very accurate with that. If you're in an orbit higher up and they say, hey, you're wanting to raise the orbit, or there's some other space article that you're on a collision course with, or possible collision, and you want to maneuver out of the way, you have to know exactly where you're going and how fast and how far you're going in order to get out of the way without running into somebody else, right? So learning the ADCS is all about that, and this is the first step in it. The CubeSpace ADCS, I see us going with that in Golf 1 as well, and they've been a really good partner for that. They're fairly new, and but even though they're over in South Africa, it's actually kind of handy, because you can send an email at 10 o'clock at night and you'll have an answer at 8 o'clock in the morning because of the time difference. But so they've been really easy to work with. The pricing is, I don't know, seems reasonable to me. It's something that always with golf, I said back in 2017, hey, this is going to cost a lot more than Fox ever did, because Fox was built cheap, because it was, again, KISS principle in that sense. And it worked really well, a lot of good stuff, but now we're getting into stuff that's up for places where we have to maneuver, we have to be very exact. We don't have the resources to build an ADCS yet. There's people working on it, thinking about it anyway. There were some that were working in ASCENT. And so that's where we go with the ADCS. It's exciting what we have available there. Part of the reason that we have all this work on the stack that's being done is how to fit it in there, what the final product was going to be that we were going to need. And that's kind of a chicken and egg thing, because right now we're at the position of having to complete the idea of the space frame with the solar panel wing deployed well enough to provide them with center of gravity and moment of inertia to allow them to make the best recommendation for the ADCS that we need, the type of control. You see in the picture here, and I think you can see my mouse. Let me check that real quick. Mouse. Yeah, good. So mouse, right in the middle. That's the, well, not the, but like the CubeSat ADCS we're going to fly. And on the top, you've got these three little boxes. Those are the reaction wheels. The reaction wheels are one way of turning the satellite. You spin these, and say you spin this one in front of me, and that's going to cause that little knobby end there. I don't know if that's a camera or not, but the little knobby end to start rising up around that axis, right? And so there's also going to be magnetorquers, or that's the use that AMSAT's always called them. Anyway, magnetorquers, which are just electromagnets that go along the sides of the satellite, for example, that can turn the satellite, but also are used to desaturate the wheels. The wheels, every time you try to maneuver something, you got to spin them a little faster than they were because they reach an equilibrium, and eventually you're going to top out. So that's what the magnetorquers help, to let you kind of wind down the wheels, and the magnetorquers hold it where it is. That's very simplification of it, because I'm not a ADCS guy, but that's how that'll work. So it's going to be exciting. It's going to be great to have something that is developed. It's a reasonable price. We're way behind, but we've had time to work with this and get it to it. And as I've said, end of 2025, next year, which is not that far away in building a satellite terms, we will have this ready to go on a rocket. Now, that doesn't mean it's going to launch then. That's a matter of, NASA's been very good at finding launches, because we want to go places that a lot of people don't. They want to go places that are lower, quicker, shorter. We're fine with, hey, it took, gee whiz, 7 years to get here. So if we got to wait another 6 months or a year to get off the ground, okay, we want to go where we want to go, high and greater orbit, larger footprint. So, but I think that what they've had, and they start looking when we do CDR, which will be around March of next year, they're going to start looking. And we should be able to launch early 2026 would be my guess. And so then let's see, I think it's about worn out the ADCS there a bit, but if anybody's got any more questions or wants more details, let me know. It is interesting to get into, launch into a talk about it and try to remember if I covered everything. So back to what Paul had said, update on the progress of Fox Plus. Fox Plus is, I think I got that on here. I can't remember if Jonathan and I shared the same slides or not. There we go. There's some Fox Plus stuff. Fox Plus is going to fly. The progress of it is being new like it is. We've actually got a new set of engineers, if you will, going to it. Although there's a lot of experience, of course, with the people working on golf, the old timers, if you will, that is being shared in what's going into the Fox Plus model. But the Fox Plus will fly a space frame, solar panels, and EPS, or electric power supply, the batteries and MPPT and all that stuff, is provided by ISIS Space. ISIS Space over in, I believe it's Netherlands. They make commercial stuff. And so Fox Plus A is going to be built largely out of commercial stuff. But the innards, as you see in this representation here, are made up primarily of, I don't know, I'm not quite sure what the red thing is, but the three boards there pretty much represent the LTM. So the LTM, the same thing is going to fly on Golf, is going to be the basis of the radio, the guts to it. And it's not going to have much else on it. It might have, actually, there's no reason to do a whole lot with it, because, again, the KISS principle, right? So what we're looking at is to get this to space. The whole idea of the Fox Plus is that with one U that are not going for the necessarily highest orbit, but the easiest way to be able to put things in space as they develop, and have an amateur radio launching every year or somewhere in that range, maybe a year and a half, depending on how long each one lasts, but to keep stuff going in LEO. So LIHU will be the first one. FM is another project that's coming along with basically a multi-channel FM repeater So it would have, I believe, 4 channels is the idea. So that instead of just one, when the Fox 1A through D would go by, you'd be having one channel up and down. And this would give 4 channels, a little more chance for QSOs or grid squares, whatever you want to do. So Fox Plus, as it develops new radio technology and stuff that can then be also carried over to golf, but it also keeps populating things into orbit sooner so that you don't run into the dry spell, if you will, where all the Foxes have died or re-entered now, and we're still working on the golf. And Fox Plus will definitely be able to carry more intricate, what am I looking for? Well, I'll put it this way. It can be made bigger. It can be a 2U or a 3U, depending on what we're doing, but it can carry on a lot of that testing of the new technology we're talking about for golf, like our guys in ASCENT working on propulsion right now. There are some people in ASCENT that are working on propulsion for golf tee, not golf tee, but the golf, ultimately, golf and beyond, to be able to provide that portion of what we need. But for us to do that, we're going to have to prove that article itself, and Fox Plus is a great way to do it, to be able to prove that it does what we need it to, it's safe, it is reliable, in order to be able to say to NASA or FCC holds the keys by granting the license or not, that yes, we can take this and we can go it to a higher orbit when we could deorbit it primarily is what everybody worries about. But and we can maneuver it to stay out of the way because we've got the ADCS and we'll have propulsion. The propulsion has been tested, et cetera. And so Fox Plus is a really kind of an interesting combination of a test bed and also just keeping a lot of amateur radio satellites up there. And they'll have a variety of radio opportunities to go along with that. So that'll be cool. Speaking of which, this is the ISIS, I call it ISIS, that's what they used to be. ISIS space antenna. This is what the VHF, UHF antenna looks like. And these little whip thingies just kind of tuck in there and fold out when you trigger it. So that goes on the top end, if you will. Doesn't matter really, but the top end of the satellite. And when it's in orbit, you pop them out and off you go. I guess this would be the EPS, or at least an example of it. You see the battery cells inside there, and then the circuit board integration. Notice the footprint of it is where the holes in the corners are. Your basic 4-inch square, give or take, how that comes together. And of course, here's the LTM that goes into it. So that, I think, pretty much summarizes Fox Plus. We did have a change of course with it a little bit. Not so much course, but as you know, Jonathan Brandenburg, when he came on board a couple years ago, it was his idea of the Fox Plus, because that was something that the board was interested in, was we need to get more satellites up there. So Fox Plus worked out well with that, with ideas that he had, opportunities that he had. And so he started that project and started bringing it together. Unfortunately, when he stepped away, then we have a void again. And Mike Moore has, he was working on the project. He was systems engineer, and now he's agreed to elevate that to be systems engineer in charge of the whole thing. So of course we all work together. That's how this team works. Is it's all a team. I get to say the last word, and whether it's right or wrong, I own it. But so we work together. We share everything, share ideas. We coaching each other, coaching Mike and stuff. So he's come a long way with that too. And Fox Plus is developing quickly. I think he's talking about. He's saying it could be ready at mid-next 2025. I'm a little more skeptical on that, and I'll just say it just because of experience. But so that's why I'm saying, I bet you it'll be a race with Golf T, end of 2025. But in any case, we'll have some stuff ready to go pretty soon with that. And then after that first one, with the experience that goes with it, with the development that goes with it, from all the people putting it together, then it makes Fox Plus B that much easier and able to expand itself, just the way like Golf T and Golf 1 shall do. Now I think really you can kind of segue over into ASCENT with this a little bit. We've got, looking for a slide, but okay, there's nothing that was included in there specifically that I see. ASCENT, well, here's some here. ASCENT projects. Right in the middle, PACSAT. You've probably heard about PACSAT. That's something that really old head, and I'm joking, Bill, I can't think of his last name, Bill Reed. Bill Reed, if you remember that graph at the beginning, he's heading up that project. And PACSAT is a 4-channel up, 1-channel down digipeater, store and forward type of thing. That can be ready to fly in early 2025. So right now it is planned not for Fox Plus A because Fox Plus A is the beginner model, the learner, but Fox Plus B will be a good candidate to be able to fly that. Not only Fox Plus B, but along with LTM, PACSAT will become part of our offerings to other partners, universities, whoever, typically universities, that want to fly a CubeSat with an amateur radio in it. We provide the radio, we get an amateur radio satellite without doing the building the whole satellite. So PACSAT's right up there to be something that'll be coming out in the next year. The FM transponder, I mentioned that. SDRB, I mentioned that. There are a few things here, SSTV payload that's being worked on, and that is something that is primarily linked toward what's called KidSat. And now KidSat, I think is a little bit, I'm not certain if they're going to actually go buy something to launch that, or whether it's stuff that will be incorporated into Fox Plus. So the SSTV payload in its current incarnation will simply be sending in SST format preloaded images. So kind of like ISS does most of the time, that they're sending the stamp collector images, if you will, of the various astronaut or historical things to do with astronauts in space. That's what SSTV payload would do initially as part of the stuff for KidSat, for the learners, to take the stuff down to, elementary grade, I guess you'd say, things that are interesting to kids, hence the name. But they're interesting to everybody. I mean, look at all the people that tune in to look at the images from ISS, which is a great platform for that because their radios are so good. You could, you can sit outside eating a hamburger and copy images, right? Let's see what else we got here. So there's a couple other things related. Environment Center. That is not anything that's active right now. I think that we've had some people come and go. Real life gets there, so you have to start on something, maybe, and then you have to back off and go take care of real life. So that's another part of the reason that we're our number one worst enemy as far as risk. But that's what this is. It's a hobby, right? So everybody who's doing it 4 to 5 hours a week, you work on something a little bit, and that's part of why it takes so much time. Or 45 hours a week, some of us, just because we're stupid. But, it's just an addiction. It's a thing. It's the ham radio hobby. So it's kind of all into this stuff. But real life comes along and it's like, oops, sorry, no time for the hobby. And that's where the environment sensor went, I believe, although that may be picked up by the SSTV payload team. I think it just got higher priority on the SSTV. Same with the space-based environment sensor. That's I'm thinking for a second. I mean, that's still something that's an active idea, but I don't think it's an active in process. GPS payload, well, I'm not sure what that is specifically. We've got GPS going into Golf T and Golf 1, and a reaction wheel controller. Now, I mentioned Attitude building our own ADCS. We had someone who was working on reaction wheel controller. Jonathan actually had found someone. That person had to step away. So reaction wheel controller had some work done with it. They actually took it to Vibe and found out that the axle was not a great idea, and but still, that's how ASCENT works. That's something that somebody can pick up, probably will, and we start to develop our own stuff to build our own ADCS someday. Why? Because these guys are interested in it. That's why. The question has come up as to why would we build something that is not our forte? It's not a ham radio, essentially. And the reason is because people are interested in doing it. That's what makes all this go. I mean, people are interested in doing this or that. So if you're interested in doing this or that, I'll give you that opportunity. If you have to give it up, okay, that's part of life, right? So ASCENT is a really great place for it. Now, ASCENT also recently went to being open source, if you will. So the projects in there, and I always say open source, if you will, because I've heard people argue, well, it's not really open source, it's open access or whatever. Okay, it goes on GitHub. How's that? So the ASCENT projects are all in the open. Now, the space frame and solar panels, deployable solar panels specifically that are being designed for Golf 1 are being done under a grant by ARDC, Amateur Radio Digital, I think, Corporation. They have been writing grants for a lot of amateur radio stuff. And so they're underwriting the development of the 3U space frame and deployable solar panels, as that's going to be an open source or open access project for people to be able to get a cheaper space frame than going to ISIS Space or Pumpkin or whoever to pick theirs up, just like we give away cheaper radios. And so ASCENT is very good. For a long time, the idea of going open source has been there, but I've never, and that was when ASCENT was quiet. ASCENT became quiet as soon as Golf started because all the engineers that were in ASCENT, I sucked all their projects over into Golf, and so they came with them. ASCENT went kind of dormant, and now it's waking up again. The reason I would not do open source with a project that's already underway is because we have NDAs, we have ITAR, not so much anymore, but we have export rules. There's all sorts of things that you can't just put out there. And it would be a job and a half just to sort them out, to try to put in what's on GitHub that you can do or what's not. So, but ASCENT, perfect place for it. Come and play, develop stuff, here we go. And that is how we're getting along with ADCS and Fox Plus, basically. And don't know if anybody's still out there. Getting fun, though. So I'm going to take another drink. What else? Well, what about way into the future? The upward to heel was a phrase, I guess, an idea coined a couple years ago, I think, about what is our vision, right? The vision has always been a little bit elusive in a sense as far as specific satellites, because it does have to do with who's around to build what, unless you want to go buy a bunch of stuff. Now, buying things is fine, like we're buying parts for Fox Plus A. But in general, if you look at every amateur radio satellite that AMSAT has ever built, it was built, right? There are some things that were purchased, but I can't really think offhand that you could argue maybe that like AO51 was purchased, but it was also designed and a lot of stuff built by AMSAT as far as I know. So that's why we do what we do, and that's why we get what we get in a sense. The upward to heel is something that's just always been what I've been pursuing because that's where we used to be. And then all of a sudden we have all these puny LEO satellites going around that are arguably a step back from where we were. The trick with what we have is that the HEO satellites and just every satellite that came before Foxes and Golfs were all like bigger formats, right? CubeSat is tiny. CubeSat is great because it is a standard format that you can get launched a lot easier than any bigger chunk, right? Basically. So in the past, the bigger chunks were a lot of times they were built to a certain shape to fit onto a certain launcher, as ballast or whatever the reason was. So we're kind of doing the same thing now, except that the shape is the CubeSat. And the trick with that is you go up to HEO, it takes a lot more power. It takes a lot more robust design especially for the radiation. If you're in HEO, you're going through the Van Allen belts all the time. So you've got the radiation, you've got the power, you've got the need for the footprint to take care of the power, both deployable solar panels and such, and the batteries to hold it, and then the power for the downlink, the space even for a microwave high gain antenna or an array. And that's when you get into the tricky stuff, and that's why upward to HEO becomes a whole nother, what would you call it? Not like a rerun or a remake, but it's like going to HEO again in that sense. And that's something we just have to develop for. Or go buy something, that ain't gonna happen. It's gonna cost a lot of money to get to HEO. It costs the going value of the CubeSat launch that we have for the Golf, a 3U, is the $300,000 grant from NASA is what it effectively is. And it's limited at $300,000. $300,000 will get you a 3U to LEO. So technically speaking, I know that they, if you want to say bargain for or whatever, they get a lower price because they fly a lot of stuff. But if we're going to go above HEO, above HEO, right? Above LEO, then it's going to cost us some money for that launch, because the CSLI program says we'll give you $300,000, but if you need a launch that's more than that, then you got to pick up the rest. So the MSRP for a GTO, geotransfer orbit, which puts you up there kind of like basically in a HEO, is for a 3U, $900,000. Now that's, you can get it cheaper, but just for base price, that means that we would have to pay $600,000-ish, call it $500,000 for a launch of a HEO satellite, regardless of whether we buy it or build it. So there's a couple things that come into play. One is I see that if we're going to do our own to get there, which makes sense, then what you're going to look at is that we want to know, that's what golf's about. We want to have that expertise, the capability of making a satellite that is reliable and robust and will go to HEO and last 10 years or as long as they'll let us, and work for 10 years. So that's going to take development to get there. Or you buy a bunch of parts. Now, propulsion, I could see where we might wind up buying that ADCS too. But the general thing is that the guts in it, especially the radios, are all done by us. The cost then for the satellite itself, the Golf T's already into the few $100,000. So you could say probably just call it $500,000. I figure it's going to cost $1 million to put up a HEO. A HEO CubeSat, it'll be a 6U. And so if you're going to spend $1 million to do that, then it better work. It's got to work. Otherwise, you'll never see $1 million again, no matter where you're getting it, ARDC or, donations from members or whatever the heck. So we've got to build it right to get to HEO, but then that's just another part of the attraction, the carrot of doing it, is that we can go there. And I know that from talking to NASA, it might take, and it's not going to be immediate necessarily, because there's not a lot of people launching CubeSats up there, or not a lot of people carrying them, So, but you could get on a GTO launch, for example. Now that's not a 64-degree, Molniya type orbit, but it's in a highly elliptical orbit. And so, it's a little bit more equatorial. But that would be the first reach that I can see. Because, I don't know, you might get some connections. Bob McGuire, that's who from Virginia Tech. You might get some connections where you could get on a 64-degree launch. And as a matter of fact, that's included in all the CubeSat CSLIs that I put in right now, is, we'll take that. Fox 1A was actually in a 64-degree, give or take a degree there, because it rode on U.S. Air Force launch of an NRO satellite. And so it was flying to that inclination, and you can extrapolate the rest. So that'd be great, you know, to get a launch like that and be able to go up to that highly elliptical part. But AO10, AO13, as far as I know, they had to push themselves up to at least a lot of that, if not some of it, because they were basically starting out equatorial as well. So you get into a lot of propulsion. Now with something as big as those were, that's a chore. With a CubeSat, it's just, that could be a take a while thing. But then of course you have to start worrying about who you're going to run into on the way. But yeah, you could do it with a little bit of propulsion over a long period of time, and that might not hurt really. I like highly elliptical myself versus a GEO, because GEO is specific. If you put up a GEO satellite, it's US, North America, I should say. North America only. North America, maybe a little bit of South America. You can't get the whole hemisphere from there unless you just build a bunch of antennas that point a certain way. I don't really see all the people that own those very expensive satellites that are up there going, yeah, well, yo, bring in that hotel satellite or whatever you call it, and you can park it in between these two. And, you know, we're not worried about you running into us or anything. Not to mention taking up a slot if there is even one. So, but the HEO also offers the cool thing where, if any of you were around then, I'm sure some of you were, that you basically your apogee drifts in a sense. So because it's not, you know, a 24-hour orbit, so say the apogee is over me right now here, you know, 97 west, then the next orbit, we're going to rotate it out of the way, if you will, and it'll be over, I don't know, the Pacific Ocean or something. But you're still in the footprint, right, of that hemisphere. So like one day you're working Europe and, you know, maybe even into Australia in a sense. And then another day you're working over into Japan and you know, into the Far East there. Comes back around, then it's up over India for a while or something, you know, for an orbit, and it starts coming back the other way, and then you're talking into Eastern Europe and everything as it comes back through. So the HEO, I think, is just a great way to really, in a sense, provide global coverage, because if you look at it right at the edge of the footprint, you're talking a hemisphere, and a hemisphere means it's halfway around the Earth from where you are. Now, how easy that is, I don't know. I'm sure there's some of you who do, but it's going to be. I mean, it just gives that opportunity to be able to have a lot more DX, QSOs, whatever. So there. That's why I like the HEO idea, and that's why I think we'll wind up just working to get there. Because I don't even know if anybody, you know, any of the members, I shouldn't say any, but many of the members are keen on the idea of spending a bunch of money to buy a satellite. I mean, I think part of the whole attraction of AMSAT is the science that's behind it. Whether you're building it or using it, you know, it's the fact that it was all done by us, hams, right? But then I'll be long gone from this job by then, so what I think doesn't matter. At least until like, what, 2026? Yeah, if elected. Paul says AO10 made it to 25 degrees and AO40 only made it to 8. Oh, so they were kind of GTO-ish. And GTO from not Vandenberg, from Kennedy would be about a 27 degree. So, well, that's not such a bad start, at least. And AO13 made it to 60-ish. And yeah, I seem to remember AO13 being up there close. But where did that launch from? Was that from Kyoto and they walked it all the way up there? Or did it go from Europe somewhere? Nonetheless, the trick now you go back to, not back to, but yeah, you have to go back to, because it's always the baseline. There's this underlying layer of all of this fun that's called, don't knock over the coffee, that's called orbital debris. The orbital debris regulations say that you have got to be very careful and you've got to come back with it. Well, first of all, kind of the baseline is you have to re-enter, because it's based on Leo a lot here. You have to re-enter within 5 years after the end of mission. Now, end of mission is really nebulous. When is end of mission? We have statistics that show that the Foxes lasted at very close to or over 5 years. So that's a good start. So I'm thinking we could do a 10-year orbit in Leo. To get away from the orbital debris stuff, you have to have your perigee, or the entire orbit, above 2,000 kilometers. So that doesn't exist in a GTO, in a HEO type thing. Typically, you're talking 400, 600, 700 maybe kilometer perigee, and so you're still within that realm of the control of, I call it the FCC because they give the license. The FCC saying you got to come back five years after end of mission. Well, still, your mission then becomes kind of the gauge of how long you can stay up there. So even if we went to HEO right now, I'm saying probably 10 years they're going to want you to come back or be back. But as part of the whole development of golf, while we can't go higher right this minute, we're putting down we're building that another layer of the reliability to last 5 years, minimum 5 years. So that helps build on that 10-year. And hopefully it would go beyond that. But the trick with that then is that currently, even a launch to 500, 550 kilometers like Golf T, which is pushing just the limit of what we can do and still be able to re-enter within 5 years naturally without using a deorbit device. And I'll get into that in a minute. But the trick with that is that the orbits right now, and they're very dependent upon the sun cycle, the sunspot, solar cycle. They're going to last like maybe 4 years, 4 or 5. And look at AO109. It was like, of course, my time frame's a lot different because of what we do, but it seems like it was up there for a flash, and it's back. It's like, whoa, what the hell? So it's hard to prove that 5 year if you're burning up within 5 years, right? And we can't go higher until we can do that or maneuver and prove that we can maneuver and all that. So it's really a tricky thing. Now the way to get again away from it is to have your perigee above 2,000, which might be possible. Is it IO 117 that's up there at is it 3,000 or 6,000? I forget, 5,000, wherever it is in the MEO. So that's above that. It doesn't have to worry about it, but it's also flying around there in a lot of radiation, generally speaking. A launch to that altitude for us is unlikely because the rocket people aren't really going there, or at least they're not going there and they're going to take anybody with them. So if you get up above GEO, that's a possibility. I don't know about doing it, but you could get your, the whole idea is if you could get your perigee above 2,000. So if you could go to any orbit between 2,000 and GEO or beyond, 40,000, 36,000 is it for GEO? If you could do that, everything's just all happy, right? Trick is getting there. You could buy a launch. You could buy a launch to a lot of places. But, and I say but, I shouldn't say but, you can buy a launch to get there. It's going to be expensive. And so that's the whole thing. It's kind of like what I mentioned with golf. It's going to get more expensive. It's just the way it is. I guess the IO satellite, IO-117, that's up there is a 6,000, about 6,000 kilometers. And I think that's kind of in between a couple of the belts. Nonetheless, it's still pretty tough stuff. But they're riding along with, aren't they, Paul? They're riding along with something else. It's not just their own little CubeSat up there, right? So we have all these little hurdles, right? Challenges to getting even to a HEO, a GTO, to the sense that it might be simpler to go beyond that. The GTO is going to require that we take care of these orbital debris things. Now you can go above GTO, and I still would want to maneuver. Obviously, you're going to want to be able to maneuver yourself, at least to point, if nothing else, but also to be a good neighbor, a good party to the people that are up there. You don't want to run into anybody. That's just stupid, right? I mean, look at what happens. And you create all them little tiny bits up there, and it makes it even harder to get there. So that's the challenges, though. And it's going to take time, and it's going to take money, or a lot more of one or the other. But that's what keeps it cool. So we can get there. We will get there. I don't see any reason we can't get there if the determination is there. If you put in the argument of, we should go to Geo, or we should go, should we go to Heo or should we go to Geo? Again, short of the corporation, the board, deciding that we're going to do a Geo, it's not something I'm going to put forth. I don't see it. It seems selfish almost, really. It's like, well, they got one over there. Yeah, and we can't use it. So what are we going to do? Put one over here and they can't use it either? Doesn't make sense. Now, the thing that's going on anyway, where ESA's going to put up something, hopefully, I guess, Geo, that's kind of like into the Atlantic a bit, where it would cover, probably not Texas would be my luck, but it would cover into the United States. Canada's the one of interest there, though, because us and Canada and ESA are together, if you will. Okay, so there's something that bridges the gap a little bit, but still it's not a good solution to everything. If you want to Geo over the U.S., you're going to have it, and you're going to talk to the same people in Canada and the same people in Mexico or Central America all the time, and I just don't buy it. So I'll just leave it at that. Sorry. So Paul is also adding in here, in case anybody can't see it, that Kuru, is where 13 launched from. So that move up to 60 inclination, that was a hell of a burn. Changing inclination is an extremely propulsion intense activity. Raising your inclination, because you're going against the travel of the orbit. If you're raising your apogee or even raising your perigee, you're doing acceleration or deceleration in the same plane, in the plane that you're in. But if you're trying to change your inclination, then you're trying to push across that, and you can only do it for best results at certain parts of the orbit. And I learned all this from Kerbal Space Program. So you got to push it. It takes a lot more burn, a lot more propellant, blah blah, and to get it there. And with a CubeSat, that could be a tough haul. So this has been fun. I hope it makes some sense. And I hope everybody's still there. I don't know if anybody came or left, to tell you the truth. I'm really glad that everybody joined, especially John from Fairbanks. That's cool. Because I'll have to tell my wife. She's all excited about this. It's a cruise tour thing, right? So we do the land tour first. Princess Cruises, so we're going to go to Princess Lodge in McKinley, and then on up to Princess Lodge in Denali, and do a bunch of hiking and stuff. And I got these super cool ATN Corporation, ATN binoculars that are, they do night vision, not thermal or anything like that, but IR illuminated, and they do range finding and stuff. And I got them because they're a cool toy. Might help find the cats at night when they're out there and they don't want to come in. That's my selling point. But also for the cruise, it's going to be cool, and you can take a picture with them. They got an SD card in them and stuff, and so I was kind of giving them a quick look last night, and it's pretty cool. You're just really looking into a TV screen, which I'm not unfamiliar with doing VR stuff. Got my left eye's going. I had a separated, vitreous, and so it creates this floater that's in there that's kind of a PITA. Anyways, doesn't stop me from doing this. Been a lot of fun doing it, I'll tell you that. A lot of work, a lot of stress sometimes too. But if you think about what we're doing, and that's what's hard to convey. there's a lot of stuff going on that, I'd have to sit here like this every week to report on what everybody had done that week or something, and that's obviously just not going to happen for time reasons, because I got to work. So, but it's so that's what makes it hard to keep everybody up on what's going on. So that's why this is a great opportunity, I think, to just sit here and not be constrained by anything that has to do with, the symposium schedule or what have you, and just sit here and talk about stuff and answer questions or topics and go with it like that. And then even to do it twice today, twice tomorrow, if people want to come back, or word gets around and there's some other interest and stuff like that, then that's very cool. And I appreciate Paul kind of moderating there and throwing stuff out. But because there's, like I said, there's a ton of stuff to talk about. So if I don't know, anything else? I can't believe I kind of wound down after almost 2 hours, but that ain't bad. If I could dig out some more stuff, that would be cool. With the pictures, as I mentioned at the beginning, I have a problem because not having my PC. See, I've got the entire SVN or storage on my PC, so I just pull out stuff left and right and know exactly where it is. Trying to access the SVN via web, I don't even remember what my credentials are, so I can't. And I'm pulling stuff out of what's over in some presentations I had on OneDrive, so I can go back years. But the problem with going back years, even going back to this one here from 2023, last symposium, not even a year old, and some of the stuff that we're doing is outdated, right? So thank you, Mike. I'm glad you were here. Glad you enjoyed it. And Paul won't be around the rest of the sessions. Well, I wouldn't be either if I was. I may be nuts, but you know what? This is something I just wanted to do because, like I said, it's hard to share this stuff, and I like to get going at symposium or something. Next thing you know, they're back there going 1 minute, cut, and it's like, I don't want to cut. So I think probably is a good time now, though. 7 minutes to go, but what the hey. So we do this in style, right? So go back where we started from with the clock in the background, huh? Tick tock, tick tock. I'll be back in 3 hours. So I got to go out and move some wires in our lot because they're going to come and mow it tomorrow. So I don't want them to take down my antennas with it. And eat some supper and come back and hope I can do this again. Got more coffee though. So thanks everyone. I appreciate everybody who was here. I really do. Spread the word too. If you know anybody who might want to come by and learn or talk. It might be a rerun in a sense, but then you never know what somebody else is going to bring up, right? So it could be anything from a hodgepodge of stuff. And I guess I'll just let it go at that. 7-3, thank you. Let's see if I can do a graceful fade out here. Huh? There you go, graceful. Thanks, everybody.